Hey, eighth grade. So our learning target today is I can solve one-step and two-step inequalities. So the good news for you is that solving inequalities is just like solving equations. Almost just like that. You know I was going to say that, right? There's always an almost or a but. So the hand method is going to really be our process for today, but we have a big decision to make on the end, at the end of each and every problem, determining do we keep the sign the same or do we flip the sign? And we have some rules with that. So here's how the rule goes. If or the inequality sign stays the same unless you undo an operation by multiplying, so you should be writing multiply in that blank, or if you divide, multiply or divide by a negative. So if the negative travels with you, if negative goes with. Not necessarily if there's a negative in the problem. The key is that if the negative goes with you through multiplication or division, we have to flip the sign. So good news for you is that you are going to really solve all of these inequalities as if you solve the hand method, and you're really strong at that. The bad news is you have to make a decision about the sign at the end of the problem. The inequality sign stays the same unless you multiply or divide by a negative if the negative goes with. So those are your rules. Let's take a look here. So here's our first example. We have this hand method problem. So we're going to go ahead and subtract 10 because we take our hand, cover the variable 2x. That's a giant stop sign there. Subtract 10, copy, paste. If I haven't used it, drag it down. So we get 2x. 10 minus 10 is 0. And on the right-hand side, we have 4 subtract 10. So 4 subtract 10 is negative 6. You can go ahead and use your calculator on that if you're struggling with the integer work. Otherwise, just mental math it. Our job is to get the variable x alone, just like we do in the hand method. So we take our hand, cover the variable x. The operation here is multiplication. To undo it, we divide by 2, copy, paste. Working left to right then, we end up with x. And we have to make a decision now on the sign. If at any point I multiply or divide by a negative and the negative travels with, I have to flip the sign. So let's take a look at what we did here. When we divided, did we divide and have a negative travel with us? We divided by 2, copy, paste. We did not have a negative travel with us. I recognize that there is a negative in the problem, but we did not have the negative travel with us. So we will not be flipping the sign here. We just keep the sign the same because we just divided by a positive 2, copy, paste. We have a triangle problem here on the right, which is negative 3. Answer is x is greater than negative 3. Negative 3. Sign did not flip. So let's look at another example over here where the sign will flip, and you'll see why as we start to solve, hopefully. Hand method. So just treat this as if it's a hand method, and we have a decision to make on the end whether we keep the sign. We subtract 4, copy, paste. Working left to right then, if I haven't used it, I drag it down, we get negative 2x. Those 4's cancel, we have 10 minus 4, which is 6. Our job is to get the variable x totally alone. The operation here is multiplication, so to get rid of the negative 2, we divide by negative 2, copy, paste. So as I start to solve here, we get x, and now I have to make a decision on the sign. If at any point we multiply or divide by a negative, and the negative travels with us, we flip the sign. So let's take a look here. Did we divide by a negative, and did the negative travel with us? I highlighted in there. Negative 2, yes, the negative traveled with us. We have to flip sign. We have a triangle problem here on the right. We have 6 divided by negative 2 is negative 3. So we have x less than negative 3. So you'll notice the problem on the left, we did not have to flip the sign because we divided by a positive 2. Problem on the right, we divided by a negative 2, so sign flips. So just take a look at the difference between these two problems. That's really the difference in this entire lesson is right here in those two example problems. Problem solving question number 1. Let's talk a real world question. So suppose you want to buy a shirt at a clothing store. You can spend at most $20. So the word at most, what does that mean? We should be thinking about that as we start to solve. You have a coupon for $5 off any item at the store. That's important information. I'm going to go ahead and highlight all important information. Which inequality can you use to find the original price of the shirt you can buy? So we want to know what is the most that we could spend on this shirt with a $5 coupon, and the most amount of money I have is $20. So as we start to solve, we really have a situation where we have a price, and then we're going to take off $5. So we have a price, take off $5, And all of that at most, which means less than or equal to 20. So we could spend exactly 20 or less than 20. I can't spend $21. I don't have $21. So I have $20 left to spend. What is the total amount that the shirt could possibly be with my $5 coupon? And the most I have to spend is $20. So you should be looking at B here. Everybody take a look at B. The price, take away your $5 coupon, has to be less than or equal to $20. B should be your option. So let's go ahead and solve that inequality then. So as we start to solve, P minus 5, the $5 coupon, is less than or equal to $20. Hand method kicks in here. To solve, we're going to add 5, copy, paste. Working left to right then, we have P. Those 5's cancel, less than or equal to $25. Now, the decision is, did I multiply or divide by a negative at all in the process? Because if I did, I'd have to flip that sign. I did not multiply or divide at all in this question, so I don't have to worry about that. So the greatest the price the shirt could be is $25 or less, because I have that $5 coupon. So we would go ahead and graph that. We put 25 in the middle. We're going to 2 less, 2 more it. So as we go ahead and put 25 in the middle, 2 less would be $24. And $23, 2 less, 2 more. And 2 more would be $26, $27. We have a closed circle at $25. So we're talking about that it could be equal to 25 or it could be less than $25. We're shading to the left there. So the price of that shirt could be 25 or less with the $5 coupon. The most amount of money I have to spend is 20. As I start to solve then on the next problem solving number 2, really good question here on the range of values that will make this work. You're checking bags at an airport. Bags can weigh no more than 50 pounds. So the question is, what does that mean? No more than. Well, could it weigh 50 pounds? Yes. Could it weigh more than 50 pounds? No, because it very clearly says no more than 50 pounds. So we're really talking about less than or equal to 50 pounds. That's what they will accept in our bag check-in. Your bag weighs 16.8 pounds. Find the possible weights in pounds that you could add to the bag. So if you wanted to put some additional work or additional stuff in the bag, what could you add? Well, your bag is already 16.8. What else could you add for weight so that you stay within the range of less than or equal to 50 pounds? Because it says no more than, which means at the most it could be. So we're going to go hand method here and solve. As I start to solve, I'm going to subtract 16.8, copy, paste. Working left to right then, we get the weight is less than or equal to 50 pounds. Take away the 16.8 that you currently have, leaves you with another 33.2 pounds that you could add to the bag and still be within the range. So here's our table, our graph over here. We have weight. I'm going to go ahead and put the 33.2. We're going to keep it in tenths place here. In the middle, we're going to 2 less, 2 more. So 2 less than that would be 33 in the tenths place, 0.1, and 33.0. 2 more than would be 33.3 and 33.4. We're talking about all the possible weights that you could add to your current bag. We're going to have a closed circle at 33.2 because it could be exactly equal to that or anything less than that I can add to my bag and still be in the okay range where I wouldn't have to pay additional fees as I check through security. All right, our last problem of the day, and before we hit that summary. An MP3 player costs $80. Lynn is going to save money for the MP3 player by babysitting $15 per week. So $15 per week. She already has $32 saved. That sounds like a y-intercept to me, a beginning amount that she has saved, and it sounds like a slope for 15. Write an inequality we can use to find the minimum number of weeks Lynn must babysit to have enough for the MP3 player. Now, of course, she needs exactly $80 to pay because the store's not going to take any less. But it's okay if she has more than that. She could just put that in her bank account. So think about what the sign should be here. So let's go y equals mx plus b here. We have a slope of $15 per week. She already has a beginning amount, a y-intercept of 32. She needs to make more than or equal to 80. 80 exactly will get her that MP3 player, but more than is okay as well. So we're going to go ahead and go hand method on there. So there's my inequality. I'm going to subtract 32, copy, paste. Working left to right then, we get 15w is greater than or equal to 58. As I solve then, Putting that W well alone, we're going to divide by 15, copy paste. Hand method, we get W is greater than or equal to 58, divide by 15. And I end up getting 3.2. So 3.2 weeks at least she would have to work. So 3.2 would be in the middle. We're going to go by tenths here, 2 less, 2 more. So we have 3.0. 3.1, 3.0. 2 more then would be 3.3 and 3.4. So 2 less, 2 more. We have a closed circle at 3.2 because it could be exactly equal to 3.2 weeks, or it can be greater than 3.2 weeks. So we have 3.2 weeks or more, shading to the right. So all of that would give her enough money to pay for that MP3 player that she wants for $80 or more. All right, so for our summary today, in our summary section, remember it's just like hand method. It's just like hand method, but if you multiply or divide by a negative at any point, you have to flip the sign. We've had that same summary for 2 days, but just a quick review on that. It is just like the hand method, but if you multiply or divide by a negative, you have to flip the sign. Your homework for tonight is to finish page 9, 10, and 11 due tomorrow. 9, 10, 11. Be very careful on making that decision on the sign. 9, 10, 11. Have a fabulous night, 8th grade.